register do a particular thing, then you know, okay, I know up to this point EAX is doing blah, and if I want to turn EAX into this, this is what we need to do. Okay? But that means that you have to keep track of EAX all the time. Okay, so if we know that EAX was a pointer pointing to the value member and I dereference it, what is EAX at this point?
Value.
It is the value of the value member. Okay, so EAX is the value of the value member. Okay, and then we push EAX, which means we push the value of the value member on the stack, and then we call, and then we push format string. So we push format string on the stack, and if you want to know what is format string, it is defined down here. Stuff that we have done already. It is just defining the string %d, line feed, and the null character, so it is null terminated, just like any other C string. So that part is something that we have done already. And then we call printf. Okay. So what we are doing is we're trying to print the integer as a signed integer in decimal. Is that okay? So, okay. So this is actually doing printf %d \n comma, and then if you want to, that's basically what it's doing. If you look at the C code,
Yeah.
it has a correspondence to the C code. Is that okay?
Add 8 to ESP direction.
Yep. Okay, so what we have to do here is to clean up all the parameters that we pass to printf. How many bytes did we use to pass the parameters to printf?
Two.
There are only two things. We have the integer value taking up 4 bytes, and then we have the address of a string taking up 4 bytes. So 4 plus 4 is 8.
8.
To clean it up, it's just add $L $8 to ESP. Okay, is that okay so far?
So are you going to take points off on the test if I don't clean up after myself?
Sorry?
I said if I don't clean up after myself, because I don't do that very well, are you going to take off points?
Yep.
Then I will design programs in which if you don't clean up after yourself, the program will crash. Yes, go ahead.
So this value itself was a pointer at the beginning?
Sorry?
List of value was a pointer?
List is a pointer to a struct list node.
No, the value member itself is a pointer.
No.
Okay, I know what you're asking. Let me show you the code. It's list node.h. Value is an integer. The member value is just an integer. It's not a pointer. Okay, so we only have a oh no, 5 seconds. I can't do it in 5 seconds.
Sure you can.
Okay, we have everything down here, making EAX point to the next member. So it's basically the same thing, Okay, I can do this really, really fast. Pop EAX. So EAX. When we saved EAX earlier, what was it? Okay, push the address of param list. That's where we were when we push it the first time. So EAX is the address of parameter list.
That's the second time that you had to pop. You had 2 pushes of EAX. But you cleaned it up with the 4.
Exactly, I cleaned that up.
Yes.
Yeah,
exactly.
so
Okay.
that's why I said you have to basically have a piece of paper with you.
Yes.
So that way you can track all these instructions and go, okay, the stack now has these things. Oh, okay, that is popped, and now we're adding this stuff here. So that would really be helpful if you do that.
Yeah.
If you don't use a piece of paper, use a spreadsheet. Okay, use a spreadsheet, which works out even better because you can copy from one column to the next. So that way you can actually have a time elapse, kind of animation of what is on the stack, what is being popped, what is being pushed, and so on and so forth. So that all will be kind of helpful. Okay, so we save EBX here. EBX has not been touched at this point, so we want to do, and locate the pop. Okay, so we store EBX. Okay, So that's how I would analyze a program, is to locate a push and then see if there's a pop, matching it at the end. Okay. So EBX is also the address of parameter list. And what is that doing?
That's dereferenced.
Dereferencing it would make EBX what? EBX now points to a struct list node, right? And then I have a missing instruction here to make EBX point to the next member of a struct list node. How do I do that?
And offset.
And this time we use next,
Next.
and add it to, say, EBX. Like that. Okay. And what would that instruction do in this case? Move L EBX to EBX.
Dereference.
Pointing to the next.
The dereference is this list node.
Okay. So this is EBX is list points to next, right?
Okay.
I really want, I don't want to use the value of, because list points to next. Next is actually a pointer itself. So I don't want to confuse, okay, are we looking at the list node, or are we looking at a pointer? But it is a pointer. Okay. In other words, EBX points to a list node structure. Okay. So now we have another thing here. Update the parameter list. Okay. In other words, update this one here. How do we do that? We have a move instruction. Moving what to what? Okay. We're moving EBX to. But that's why we kept EAX around, because what is EAX? If you look through this history here, if you go back, EAX is still the address of the parameter list. So when you assign something to that variable, you need to have what we call the left value, which is the address of list. So when you dereference the address of list, then you get the list back, and that's why this will complete the instruction. In other words, if I want to comment this line here, this will accomplish list equals list points to next. Okay. That's the nature of this type of question. I will give you a program otherwise correct. Otherwise it's done correctly, all the offsets are done correctly, all the other instructions are also correct. But it has missing instructions. And will tell you what each instruction is supposed to do, its role in the entire sequence of instructions. But then you have to figure out, okay, if I have to use only one single instruction to accomplish this task, given all the registers, given the stack content at this point, how do I accomplish that task? Okay, so in this case, the disassembler, guess what? Won't help. Because the disassembler will very unlikely to choose the same type of instructions that I choose to use. It may help you a little bit as to, it looks like this in one version. You may be able to correspond, okay, that instruction of what the compiler chooses may correspond to these instructions over here, but I think that will actually slow you down than speeding you up. Okay, but that's just my take. Okay, you can just take my word, or leave it as such. Okay, do we have any questions at this point about the exam? There's one more question that I have not explained. I will give